Some things just happen by accident, like missing your bus stop or putting your shirt on inside out or mixing up salt with sugar. But when accidents involve volcanoes, that's another level. In 2009, Iceland's energy company, Landsvirkjun, worked on a project to drill a deep geothermal well in Krafla, a volcanic caldera. They were trying to drill nearly 3 miles down, but the drill kept getting stuck, over and over again at the exact same depth. By the time the workers managed to get the drill unstuck, they found pieces of glass, hardened, crystallized, melted rock. That's when they realized what the drill had hit. They'd actually drilled straight into a volcano. It was total shock. Nobody expected there'd be a volcano, or technically a magma chamber so close to the surface. These pockets of scorching hot molten rock exist around volcanoes, but they're normally much farther down. And they're definitely not something people stumble upon by chance. Worried this might lead to devastating consequences, the team quickly cooled the well by pumping in around 1 million tons of cold water and eventually shut the operation down entirely. 15 years later, a different group of Icelandic workers is getting ready to do this on purpose, drill into a volcano. On top of that, scientists and engineers hope to harness the immense power of magma to tackle the planet's biggest challenge. Which one? Energy, of course. Good thing I don't need magma for energy. Just some coffee will do. Just an unobtrusive reminder for those who forget to hit the like button, don't forget to do it. If liking isn't your thing, don't do it. And thanks to those who get my wish to stay anonymous. To begin with, one should say that drilling wells to harness energy isn't anything new for Iceland. Geothermal energy has already turned life in this country upside down. Just about 80 years ago, Iceland relied mostly on oil and coal, but now over 90% of homes are heated using geothermal power. This clean, constant, and steady energy turned Iceland from one of the poorest countries in Europe into one of the wealthiest. In just 25 years, the use of geothermal energy skyrocketed by 1,700% thanks to a deep drilling project. As part of this initiative, wells were drilled all over the island to depths of about 3 miles. And there are thousands of them. That's how geothermal energy is harnessed, drilling into hot underground areas to get steam. This steam powers turbines, which produce electricity. And so around 70% of all energy used in Iceland comes from geothermal sources. The best part is that this energy is a renewable resource. The Earth keeps generating heat all the time, so geothermal energy sources can last for decades or even longer. Plus, unlike other renewables like solar and wind power, hot steam is available 24/7, 365 days a year. And all of this is a unique thing about Iceland because geothermal energy is less than 0.5% of the energy used worldwide. Iceland is among the top 10 countries in the world for energy production today, and it's next to countries such as the US, Mexico, Japan. You know, the ones with way more land and way more people. So Iceland is planning to drill into a volcano. It's still about the Krafla caldera, located in one of the most active volcanic zones in the world, sitting right along the tectonic boundary of the Mid-Atlantic Ridge. Eruptions, or what they call volcanic events, have happened here repeatedly, with the last one back in 1984. Scientists have figured out that over the last 1,000 years, Krafla's erupted about 30 times, making it a pretty active volcano. If you look at the bigger picture, it's clear that Iceland is the perfect place for harnessing geothermal energy. Look here. In this image, the lines represent tectonic plate boundaries, and the dots show volcanic eruptions since 1960. Iceland might be small, but it sure has a ton of these dots. It's not surprising since the island has more than 200 volcanoes. It's believed that volcanic activity is what made Iceland an island. It used to be a magma hotspot, and over time, hot lava rose to the surface, cooled down, and formed the island. So Iceland is used to volcanoes. It has an eruption about every 5 years, although most of them happen in uninhabited areas. Overall, there's plenty of geothermal energy to tap into here. Krafla, despite its unpredictable nature, is the perfect place to go beyond just extracting super hot steam. Its magma chamber, where temperatures reach 2,372 degrees Fahrenheit, is located just 1 to 2 miles beneath the surface. Add other bonuses that are above the surface. There's a power plant, high-speed internet, and an asphalt road. Yeah, on top of the volcano. Iceland as it is. But what's the idea behind intentionally drilling a volcano? It's all about the first connection to the magma. The project is called Krafla Magma Testbed, or KMT. As part of it, people will drill into the magma chamber of a volcano to use its super hot steam to generate energy. And this will be on a massive scale. If everything goes as planned, KMT promises to supply homes across Iceland with a renewable, unlimited energy source. Let's face it, the idea of turning all that heat and pressure into a new, endless form of super powerful geothermal energy is a tempting prospect. The entire world is literally working hard to ditch fossil fuels and stop warming up the planet. But no one has ever thought about using the Earth's hot core for this. The director of the Geothermal Research Cluster, which developed the project, compares its scale and ambitions to the James Webb Space Telescope, the very one that gives humanity the unprecedented chance to see the universe. And while drilling into a volcano won't give us quite the same view, it could potentially, well, maybe save the planet. Drilling will start in 2026. But hold on. I clearly remember that throwing stuff into a volcano and just messing with it's a bad idea, because all of that could lead to an eruption. In theory, drilling could trigger it too, right? If the drill survives the journey through partially molten material, it would release pressure in it, causing a small portion of magma to shoot up to the surface. That would be a volcanic eruption, even if it's artificial. Fortunately, scientists thought about this too and came to the conclusion that, in practice, the scenario won't work. Why? Because all this already happened in 2009, but the volcano didn't react. Nothing spilled out anywhere, so we can keep working. If everything goes as planned, the first well will be finished by 2027, and it'll be the first time anyone has implanted sensors directly into the magma chamber. The goal is to crack the mysteries of magma, how it moves through the crust, what the temperature, pressure, and chemistry are like. Everything to help predict when and where eruptions might happen. And this is actually a historical event. Never before has humanity had a way to directly look into volcanic systems, so drilling into a volcano has several advantages. If the first experiment goes well, the research team will move on to the second well, which they plan to finish by 2029. And this could be a game changer. Because in the second well, the team will try to harness the intense heat of magma to generate a new type of extreme geothermal energy, many times more powerful than the usual kind. But before the drill reaches its target, it'll have to go through a layer of clay, soil, and rocks. This is the first and easiest stage. At a depth of about 600 feet, the second phase will begin, the structure will change, and the drill will have to go through a layer of volcanic and magmatic rocks. It's a really thick layer, so it'll take a lot of time. Then, at a depth of about 0.9 miles, very hard volcanic rock will come up, which will be a real challenge for the equipment. But finally, at a depth of about 1.2 miles, the drill will reach its final destination, the magma chamber. To make it easier to imagine the distance, let me tell you that 22.5 Statues of Liberty stacked on top of each other would fit into the well, or 3.3 Shanghai Towers. It's funny, of course, that scientists call this colossal depth just right near the surface. But let's get back to the journey, not to the center of the Earth. Once the drill finally reaches the magma chamber, it'll be pulled out, and then a hollow steel tube, capable of withstanding enormous heat and caustic magma, will be inserted. After that, they'll fill the outside of the hole with concrete, and then, using a smaller drill, they'll begin to penetrate the magma, collecting samples and implanting sensors. Naturally, there will be challenges, but scientists, engineers, and workers are ready for them. The location of the volcano makes drilling into the magma chamber both relatively simple and incredibly complex. I mean, the drilling depth isn't that big, but the drill bits have to withstand extremely high temperatures without melting. On the other hand, we know for sure that this is possible thanks to what happened in 2009. That very accident revealed important details about the liquid state and dynamic interactions of magma, even though the steel casings of the drill were destroyed in the process. On the other hand, this intrusion also showed that exposing the magma chamber doesn't necessarily lead to volcanic eruptions. I've mentioned this before. Scientists from KMT are still experimenting with materials that can withstand these conditions, but they still have time. Moreover, it's not enough to just drill a hole down to the magma. The well has to remain stable for decades. Plus, scientists still don't know how magma stays hot at such a shallow depth when it's trapped in much colder rock. One hypothesis is that the magma chamber is so huge that the cooling effect from the surrounding rock is insignificant. Another hypothesis is that heat comes from some unknown element deep down below. In any case, there's not enough data, and it's unclear whether the magma will stay hot throughout the lifespan of the geothermal well. And then I thought I should probably explain why magma has some advantages over superhot steam. Well, scientists are convinced that using the extremely high temperature of magma right at its source, it's basically the same geothermal energy, just on steroids. Instead of the usual mix of water and steam brought to the surface with regular geothermal energy, scientists will get super hot steam. The energy from magma, the power produced by magma at 3,272 degrees Fahrenheit, is 10 times greater than that from regular geothermal energy, which reaches temperatures of about 392 to 572 degrees Fahrenheit. Anyway, you get the idea. Using higher temperatures in the magma chamber can really boost the energy output, making it much more powerful than regular wells. The water in the magma chamber doesn't form as steam like with other geothermal stations. Instead, it's more like a supercritical fluid. This is water that's so hot and under such high pressure that it's neither liquid nor steam. One magma-based geothermal station can produce at least 10 times more energy than a regular geothermal one. Oh, and I've said that already. If the project is a success, the Icelanders will get huge amounts of energy and also advanced science, being able to study volcanic activity with new techniques. And that'll make eruption predictions better too. Drilling into the magma chamber will also offer an unprecedented chance to observe a volcanic eruption right from its source. For a long time, volcanologists relied on indirect methods to study magma. Now it's time to go straight to the source. Remember Eyjafjallajökull, which caused chaos in 2010? The ash cloud led to over 100,000 flight cancellations, costing an estimated $3.95 billion. But if we'd been able to predict the eruption better, the world could have saved a ton of money. And if the volcano drilling project is successful, this could really become possible in the future. And the icing on the cake, the savings. The wells needed for this magma-based energy will be about 2 to 3 times more expensive than regular ones, but far fewer wells will be required. 18 standard wells in Krafla that produce enough electricity to power about 30,000 homes could be replaced by just 2 magma wells. Can you feel the difference? If you're curious about how magma's energy gets turned into electricity, it's pretty simple. First, super hot magma steam is pumped up from the ground into a heat exchanger where it flows through pipes filled with water. The water boils and steam forms. The steam rushes out of the heat exchanger with a roar, spinning a turbine to generate electricity, while cooler magma liquid is pumped back into the ground, and it heats up again. Steam exits the turbine and enters the cooling tower, where it turns back into water. The water flows back into the heat exchanger, resulting in a continuous loop. If Iceland pulls this off, other countries might follow its lead. It's clear that the best spots for magma energy extraction are active volcanoes with relatively shallow magma chambers. Some of these have been found, for instance, in Kenya and Hawaii. The most active volcanic regions in the world might also have accessible magma chambers, including the so-called Ring of Fire in the Pacific Ocean, which covers California and Japan. This map shows where volcanoes are located in the areas being considered for drilling. And it's not just about the Ring of Fire. There are plenty of active volcanoes all over the planet. It's true that on many of these plots, they'll probably have to dig much deeper than at Krafla well to reach magma. That's going to make the process even more expensive. But if magma-based geothermal energy is as powerful and efficient as it seems, all the expenses will pay off. You just have to wait. By the way, Icelanders have drilled into a volcano on purpose before. To get a pure sample of volcanic material, volcanologists and engineers bored into the massive Reykjanes volcanic system. This spot is calmer than Krafla. It hasn't erupted for about 700 years. It's not erupting, but there's always something bubbling, hissing, or flowing here. The system is made up of small shield volcanoes, lava fields, craters, and impressively young lava flows. All of it's fueled by a rising flow of overheated mantle material. The researchers of Iceland's deep drilling project, intrigued by an unusual gathering of magma beneath the otherworldly landscape, decided to grab the freshest possible sample of that bubbling madness. The only way to do it was by drilling a volcanic well beneath the surface, and in 2017 they managed to hit a record depth of 15,300 feet. Back then, they announced that besides getting some pretty fascinating geological samples, the wells would eventually be turned into something like steam pipes, the kind used in geothermal power plants. Did they actually do it in the end? I don't know. If you know, drop a comment below. Solar energy from space. You already know that renewable energy comes not only from geothermal plants, but also from wind turbines and solar panels. Still, the latter, though quite efficient, face criticism. Here's the reasoning behind it. To get energy from the sun, you need to use solar panels. There's no other way. But here's the problem. Even in areas with plenty of sunlight, it's impossible to guarantee it all year round, not to mention that the sun sets. So what do we do in that case? It's simple. Just toss a couple of giant panels into space, where there are no limits to harvesting solar energy. And these are not my fantasies. For decades, scientists have been studying the possibilities and prospects of using solar energy from space, and now it looks like this idea could become commercially viable. And pretty soon, too. Recently, a UK company called Space Solar teamed up with Iceland's Reykjavik Energy to create an orbital solar power station. This project, planned for launch in 2030, will be able to generate about 30 megawatts of power. To put it in perspective, this amount of energy could power between 1,500 and 3,000 homes. But how is this all going to work? I mean, how will the energy from space reach the Earth? It's not complicated. The system will use solar panels in space to harvest sunlight. The energy gathered will be turned into radio waves of a specific frequency and sent to a ground station. Once it reaches Earth, the radio waves will be turned back into electricity and fed into the power grid. It's expected that the system will be like a kind of satellite, and if all goes well, it'll be the heaviest object in space that isn't a space station. According to the plans, when fully deployed, the solar power system will be bigger than the ISS. Again, if everything goes as planned, the companies aim to launch an upgraded version of their design by 2036, which will be able to generate gigawatts of electricity. So let's wait. Dangerous neighborhood. Let's go back to volcanoes for a moment, since that's what today's video is all about. In January 2024, a volcanic eruption took place on the Reykjanes Peninsula in Iceland. Yep, the one that hasn't been active for 700 years. The ground literally cracked open in an active zone, and the lava flow reached the town of Grindavik. Protective structures had already been built to redirect the lava, but the crack appeared outside those barriers, and the molten mass reached the town, setting some houses on fire. Why am I telling you all this? To help you understand what price Iceland pays for the ability to use geothermal energy. Due to the eruption, the residents of Iceland faced serious problems because they lost heating and hot water during the harsh winter season. This happened because lava covered the pipeline that supplied hot water from the power plant to nearby towns. As a result, many towns had to close schools, gyms, and pools, and the authorities carried out a mass evacuation. Although the gas release from the eruption was directed towards the sea, which can be seen as a good thing, experts still consider the region dangerous for people. After a long period of dormancy, Reykjanes has become the center of volcanic activity since 2021. There have already been 5 eruptions recorded, and the latest one confirms scientists' concerns that this is just the beginning. This means that volcanic activity may continue in the future, and scientists point to the approach of a more powerful eruption due to the constant influx of magma into the Earth's crust. And we need to do something about that. Staying safe from volcanoes. Iceland has a way to keep its people warm. The authorities are getting ready to build protective barriers around a geothermal power plant in the southwest of the country to shield it from potential lava flows. As I said before, volcanic activity isn't letting up anytime soon, so it's important to be well prepared, especially since this plant provides electricity and heating for about 30,000 residents and supplies hot and cold water to the Reykjanes Peninsula. The plan calls for a protective system with 2 barriers. The first one stretches for 2.5 miles, while the second one's a bit shorter, just under a mile. And to give you an idea of how crucial it is to safeguard the power plant, they brought in 70 workers who worked in shifts around the clock. All of them faced the risk of an eruption because there was no update, and still isn't, on exactly when the volcano might erupt. Despite the risks, the work is moving forward as planned. 6 of Iceland's largest contractors are involved in the project, with some bringing in subcontractors. In short, it's a tough job. There's a ton of it. But it's hard to think of anything more important in a situation like this. Don't look up. Let's take a look at the sky. The Icelandic sky, of course. This country's famous for its stunning northern lights that you just can't stop staring at. But this love for nature can sometimes lead to unexpected trouble. Back in 2015, the Icelandic Road and Coastal Administration raised concerns that foreign drivers were causing accidents by pulling over on the side of the road just to snap photos of the northern lights. Sure, Iceland has plenty of other attractions like glaciers, volcanoes, lava fields, and all that, but nothing quite compares to the glowing sky. Drivers seem to agree, getting so mesmerized that the police actually think they're drunk. The first case of a drunk tourist being caught happened on the Reykjanesbrau highway, and the second one was in the small town of Njarðvík. Both incidents took place on the scenic coastal roads between Iceland's main port and the capital, Reykjavik. However, after police checks, it turned out the tourists were completely sober. They just couldn't tear their eyes away from the northern lights and weren't paying close attention to the road. And honestly, it's hard to blame them for that. Fly away, bird. On the Westman Islands in Iceland, you can witness a brutal scene every year, people throwing thousands of little puffins off cliffs. But don't rush to judge Icelanders for cruelty. This is a tradition, and it's crucial for the bird's survival. Atlantic puffin chicks are born in burrows on tall seaside cliffs, and when it's time for their first flight, they leave their colonies to spend a few years out at sea. Normally, the chicks navigate to the ocean by following the light of the moon, but these days city lights confuse them, so they need a helping hand. Many chicks lose all sense of direction, so locals pick up these lost ones and then release them from the cliffs. Experts say that puffin chicks should be released before sunset because if it's done at night, they might get confused by the bright lights and end up back in town. But what about natural selection and all that? So a few chicks got lost? Is that such a big deal? Actually, it is. These birds who mate for life only lay one egg per season and don't always lay eggs every year. If several generations fail in a row, it could lead to the population dying out. So let them fly. You owe me a like since you've watched the whole thing. See you later.